Compressible Flow Normal Shockwave Tutorial. So before we answer a lot of questions about shockwave here, please remember all these basic equations. So from the ideal gas law, we know that P is equal to rho RT, so we could use as P1 equal rho 1 RT1 and P2 equal rho 2 RT2 if you have two conditions, and it can be rewrite as this one. Please also remember this equation. And then for shock wave, it is totally different equation from isentropic flow. So please remember that if the question asking you about shock wave, or we have a shock wave phenomenon in the question, you need to solve problem before and after shock wave by using this equation. Please remember this equation. So this is the full equation. For air, you could replace the value of K here with 1.4 and you could get simpler equation. But it is worth for you to remember all this equation. So we go for question number 18. The pressure, temperature and velocity before a normal shock wave are 80 kilopascal absolute, 10 degrees Celsius and 1000 meter per second respectively. Calculate the M1, M2, P2, T2 and rho 2 by using the equation and the normal shock wave table. By equation, so we could start to calculate the Mach number 1 by using this equation, V over C, and then we could replace the term for speed of sound by KRT1 like this. We substitute the value. For air, K is 1.4 and R is 287. We use temperature in Kelvin, so we plus 273 here. So we get the value of Mach number before shock wave is 2.966. Then we could calculate the value of Mach number 2 here after the shock wave by using this equation. We substitute all the value, we get 0.22775, and this value is actually if Mach number after the shock wave by the power of 2. So we insert it and then we could get M2 here is equal 0.477. And we could calculate the value of pressure here by using this equation, P2 over P1. We substitute all the value, we get it. The ratio of P2 over P1 is equal 10.096682. Then we could calculate the value of P2 here by multiplying with 80 kilopascal absolute here. So we get the pressure at P2 is 807.73 kilopascal absolute. So to get the temperature here, we could calculate the ratio of T2 over T1 by using this equation, and then we could get 2.639, and then we could calculate the value of T2 is equal to 746.9 Kelvin. The density after the shock wave can be calculated by using this term, rho 2 is equal P2 over RT2. We substitute the value of pressure and temperature that we get from the previous calculation here. We could get density after the shock wave is 3.769 kilogram per meter cube. And this is how to calculate the same thing, the same question by using the normal shock wave table. So this is a part of the normal shock flow table. So we have column of M1, M2, P2 over P1, T2 over T1, and PO2 over PO1 here. So and then PO2 over PO1 here, the O here is show the stagnation. So mean the stagnation pressure after the shock wave, at point 2 over stagnation pressure at condition before the shock wave is 0.1. So first we need to calculate the value of Mach number 1. I already explained about this, and we could get it is about 2.966. So we see from the table we found that there are no value of 2.966. However, we have value of 2.96 and 2.98. So mean we need to calculate interpolation from this value to get the exact value of Mach number 2. From the table, we could have this value, 2.96 is 0.4776, 2.98 is 0.4764. We have Mach number 1 is 2.966, but we don't know what is Mach number 2. So we could calculate the interpolation like this, and we could get the Mach number 0.2, Mach number after the shock wave is 0.47724, and we could simplify it as 0.477. It is better for you to simplify this value into 4 digits, because the table here we have 4 digits here, so it might be best for you to write as 0.4772. And then we do the interpolation for P2 over P1. So we have this value from the table. We could do the interpolations, and then we could get that P2 over P1 is equal to 10.099, and then we could calculate P2 is equal to 807.92 kilopascal. The answer is totally the same compared with the equation. And this is the interpolation calculation of T2 over T1. I hope you could understand this, because this is a very simple calculation. We get T2 over T1. The ratio of this one is 2.6392. Then we could calculate the value of T2 by multiplying 2.6392 times 2.83, and it is equal to 746.9 Kelvin. And again, to calculate the density after the shock wave, we use this equation, P over RT. We substitute all the value here, and we could get the same value as we calculated previously, which is 3.769 kilogram per meter cube.